All right, we're looking at this recoil example, and again, forgive me this chapter, I was a bit creative with my problem writing. So here we go. Mr. Plaza is heading to space. The crew of the shuttle grows tired of Mr. Plaza's antics on the mission. As a result, the crew convinces Mr. Plaza to go on a spacewalk to fix a faulty valve. Mr. Plaza does because he's a team player. He's pushed from the shuttle, travels to a distance of 15 meters before reaching the end of his tether and stops. The tether is then cut. Mr. Plaza has a choice to make. He can either throw the wrench at the shuttle, break the window, send everyone to their death, or, using his knowledge of physics, throw the 2-kilogram wrench at a velocity of 5 meters per second away from the ship and sending Mr. Plaza, whose mass is 100 kilograms, back to the shuttle in safety. And there's a little caveat here. The shuttle leaves in 5 minutes, so will he make it on time is our question. And so this is an example of a recoil problem because the wrench and Mr. Plaza start together and apart, meaning their initial velocities are the same. And since Mr. Plaza traveled to the end of the tether and then stopped, the initial velocity for both of them is 0. It also told me that the wrench was 2 kilograms, I believe, was it? Yes, 2-kilogram wrench. And Mr. Plaza was 100 kilograms. Mr. Plaza was able to throw that wrench at 5 meters per second. And we're going to say away from the ship is the negative direction. So Mr. Plaza is moving in the wrench will move away from the ship in the negative direction, and Mr. Plaza will move toward the ship in the positive direction. All right, so I want to figure out how fast is that Mr. Plaza going to go, and then will he make it from 0 meters to 15 meters at a constant velocity in enough time to make it back to the ship, so within 5 minutes. All right, so we need to find V1 prime. Well, we notice that the initial velocities are the same. Now, this is a recoil, so I can go ahead and say that M1 and M2, Mr. Plaza and the wrench, are moving together initially. In this case, it doesn't really make a difference because I'm going to cross them both out anyway, but here I just get to cross them all out as 1. Next, I need to go ahead and solve for V1 prime. So I'm going to subtract my M2 V2 prime over. So I have M1 V1 prime equals M2 V2 prime, and divide the M1. So now I know that the velocity of Mr. Plaza after he throws the wrench, that's what that prime means, after that interaction, is going to be the mass of the wrench 2 times the velocity of the wrench -5. And this, forgot that negative sign there when I moved it over. So I got a negative sign there, all divided by the mass of Mr. Plaza, which was 100 kilograms. So I have 10 divided by 100, so Mr. Plaza is moving at 0.1 meters per second. So 0.1 meters per second. All right, 0.1 meters per second at 15 meters, acceleration is 0, so I always use equation number 2 here. So I have x is equal to x naught plus v naught t plus 1/2 at squared is 0. Now, notice here, the initial velocity is the final velocity of this problem. And we're going to run into this in that we're going to have one problem occur, namely this recoil problem, and then after that, we're going to have another problem, a motion problem occur. And so the final velocity from the first problem becomes the initial velocity for that second problem. All right. So go ahead, plug in my numbers, and solve for t. So I have 15 meters divided by 0.1 will give me a time of 150 seconds, which is 2.5 minutes, less than 5 minutes. So Mr. Plaza makes it back in time to be a team player. Everyone says they're sorry. Happy ending.